Alright students, welcome back for another lesson. We got Chapter 5, Lesson 1, Writing Two-Step Equations. In this section, we're going to be writing equations from a problem. This may be involving real-world context, or just a simple phrase where we write a two-step equation to represent that phrase or context. If you're ready to get started, let's go to the board.
Topic 5.1.
Alright students, now that we're at the board, let's take a look at this first question. Write an equation to represent the following description. Using pencil and paper, describe a real-world situation that the equation could represent. 8 more than 4 times a number is 28. So let's take a look at this one piece at a time to break it down. First we have 8 more. What does that sound like to you? Well, to me, it sounds like you're adding 8. Then we have 4 times a number. That sounds like 4 times x. So we have 4 times x, we have 4 times x. Technically that would be 4 times x. And then it says is 28. Now the cool thing about is, that's the same thing as equals. So let's see which one of these things has all of these things together. Well, all of them say equals to 28, which is great. That works. But this one says plus 4. This one says 8 more. This is really plus 8. Then we have 4 times a number, which again we said was like 4x. So really what we have is 4x plus 8. The only one that has all 3 of these is e. So that is our answer. Alright, let's take a look at number 2. You want to buy a pet rabbit that costs $242. So let's just stop right there for a minute. $242. Now look, all of these say $242 is what it's equal to, so that's a good place to start. Alright, you already have $62. Let's isolate the $62. Oh, missed one up there. Alright, and then we plan to save $12 per week. Per week. Now listen, when you see this word right here, this word per, I want you to think about that's going to be the variable because it depends on the number of the things that come after. So in this case, it's $12 per week or $12 every week. So it depends on the number of weeks. So that's going to be your variable. And they're using W for the variable, as it says right here. If W represents the number of weeks until you have enough money, let's find the equation. So 12 per week, so it's like 12 times the variable. So if you look at a couple of these, like this one right here has the 62 next to the W, but that can't be right. So that's not our answer. Next, we have to look for anything that does not match up perfectly. See, we said $12 per week. But these, E and F, do not show the 12 with the W. They show 62 with the W, so again, they cannot be our answer. Now we're only left with a couple extra things. Let's think about this logistically. You already have $62, and whenever you see and, I want you to think about plus. So $62 and $12 per week. Now both answer B and D show a minus, so that means you're subtracting something. I don't see anything about subtracting in this problem, do you? So the only possible answer here is A. So let's just make sure that this works. We have $12 per week, which is this right here, 12W, 12 times the number of weeks, plus the 62 we already started with, and that will equal $242. That has to be our answer. Now we've got another question here. One of the banners in a parade is 1/3 as tall as it is long. It's 5 feet tall. If L represents the length of the banner in feet, what equation could you use to find the value of L? So first, let's take a look by drawing the shape. We've got our banner. The problem tells us that it is 1/3 as tall as it is long. Then it tells us that the banner is 5 feet tall. So let's go ahead and label our sides here so we can look at what we're doing. First, the problem tells us that it is 5 feet tall. So let's go ahead and label the height as 5 feet. It does not tell us the length, so we have to put L for length. The problem also tells us, though, that it is 1/3 as tall as it is long. So the 1/3 as long is represented by 1/3 times L. Since both these things, the 5 feet and the 1/3 length, both represent the height of the banner, we can make them equal to each other, in which case A would be the correct answer, because it shows 5 equal to 1/3 times the length. Our next question says, write an equation to represent the following description. Describe a real-world situation the equation could represent. Let's take a look at it again, one piece at a time. 17 less than 3 times a number is 14. Let's start with the first piece, 17 less. So let's look for one that has a negative 17, because 17 less would be minus 17. The only one I see, or two that I see, are right here. Then it says 3 times a number, that would be 3 times x, so I see it here, and then technically I see it here. Then I see is 14. So all of them show is 14, so that part's easy enough. But now we have to figure out our options. Well, we know it can't be A, because it says 17 less. We know it can't be B, because again it says 17 less. It can't be C, because neither one of those things are right. So now we're down to D and E. Now they look like they might be the same, except for, if you remember from previous lessons, in E we've got distributive property going on. So this is 3 times x, which gives us our 3x. But then we have 3 times negative 17, which is going to be way more than negative 17. So it has to be D. That is the only one that has all 3 pieces that work. That is our answer.
All right, students, now that you know how to write two-step equations, we're ready to move on to 5.2. We're going to be learning how to solve those two-step equations. So make sure that you subscribe to the channel, like the video, and then leave some comments down below so I know how to help you next time. And until then, see you later.